Let's take a closer look at the CPI, or the Consumer Price Index. It measures the average change in prices paid by urban consumers and urban wage earners for a market basket of consumer goods and services. So the BLS, they basically track all this data, they take surveys, and they say that, hey, this is the typical market basket of goods and services that these people buy on a monthly basis. They track all the prices, and they track the prices if they go up, if they go down, and the CPI is exactly the index or the price level that comes out of that. The CPI is a cost of goods index where it compares the cost of a fixed bundle of goods and services from one period to the next. So if we're interested in solving for 1 year to the next year, that's exactly what we'll compare the CPIs. If we're comparing 1 month to the next month, we can absolutely do that as well. So it's a two-step process in order to find out the CPI and the inflation rate from the CPI. So take a look at the two formulas that we're going to have right here. So step number 1 is to go ahead and define a base year and find the cost of the market basket of goods and services in that base year. So what exactly is a base year? A base year is going to be our benchmark or our bench year. So step number 1 in this instance, step 1 is to define a base year. So the base year is just our benchmark, or is our bench year. We're going to be comparing everything to this base year. So benchmark, or our bench year. So essentially with this, we're comparing all of our other CPI values compared to this base year right here. And the choice of a base year is kind of arbitrary for us. We can say that, hey, 2020 is our base year. We can say 2010 is our base year. The BLS, I do believe that they used 1982 to 1984 and averages of those 2 years as their particular base year. So base year, just choose one particular base year. Step number 2, as we've noticed, is to find the cost of a basket in the base year and also in the current period. So step 2, we'll just go ahead and find the cost of the market basket of goods and services. So find cost of basket of goods and services, So exactly how much did this market basket of goods and services cost in the bench year? How much did this market basket of goods and services cost in the year that we're currently in, or the year that we're interested in solving for? So a two-step process in order to find out the CPI and the inflation rate from this. So let's go ahead and use this first formula right here to calculate out the CPI. The first formula right here, the CPI, is equal to the cost in the current period divided by the cost in the base period times 100. So we need the cost of the market basket of goods and services in our current time period and the cost of a market basket of goods and services in the base period. So here, let's go ahead and give you a few examples of this. So example number 1. And remember that this market basket of goods and services, they are similar, or they're going to be the same exact items from the base period all the way to the current time period. It's exactly the average goods and services that the BLS says that you and I buy on a monthly basis. So suppose that we start simple. The BLS says the market basket cost says market basket cost $5,000. And suppose that we go ahead and take a look at the year 2018, just choosing an arbitrary year right here. So BLS says the market basket cost $5,000 in 2018. Now it cost $5,750 in the next year, in 2019. So once again, just choosing arbitrary years right here. Question that we want to ask is, what is the CPI for 2019 using 2018 as a base year? So question number 1, what is CPI for 2019, for 2019, using 2018 as a base year, And I will tell you specifically what the base year is if you need to use the base year in any of these calculations. So here, that will be explicitly told to you what the exact base year is going to be. So once again, just go ahead and use that first formula that we just mentioned in order to find out the CPI. So what is going to be our base year and what is going to be the current period? The current period is always going to be the period that is closest to us, and the base period is always what we define it as. So here, 2019 is the current period, 2018 is the base period. You stay consistent with the cost in each of these particular periods and insert them into the formula there. So CPI equals 5,750 divided by 5,000. So cost in the current period divided by the cost in the base period multiplied by 100, and this will give us the CPI value in 2019. So in 2019, the CPI price level is equal to 115. And what exactly does this number tell us? It doesn't give us a whole bunch of information. In order for us to make any notations about inflation at all, we need to compare two different CPI levels against one another. So here, this one singular number doesn't provide us with a lot of information. We need to compare this 115 against another CPI value. So suppose we want to go ahead and find out another CPI value. Let's go ahead and find the CPI value for the base year. Second question that we can ask is, what is CPI, say for 2018, using 2018 as a base year, So here we want to go ahead and find out the CPI in 2018, which is exactly our base year as well. What do you think the CPI is going to equal? So the denominator is very easy for us to solve because that is our base year. That's going to equal that $5,000. That's what the market basket of goods and services cost in 2018. What is the CPI, or the cost of the market basket of goods and services in the current time period? The current time period we're interested in solving for is 2018. So that would be the same exact number in this instance. So 5,000 also goes in the numerator here. So anytime we want to go ahead and find out the CPI in the year that is the same exact as our base year, we're going to have the same numbers on the numerator and the denominator. So when we multiply by 100 in this instance, we're going to get 100 no matter what. So no matter what, anytime we want to calculate out the CPI in the base year, it's always going to equal to 100. So that's something that you should keep in the back of your mind. CPI always equals 100, always equals 100 in the base year, because this is exactly how we define the formula. So 2018 is our base year. We wanted to find out the CPI in that same exact year. It's going to be the same number, so therefore CPI has to equal to 100. Now that we have two numbers for CPI, we have one in 2018, one in 2019, this is where the second formula comes in, and this is the most important formula that we're going to be dealing with for this chapter. It is a percentage change formula. So the percentage change in price, which is the inflation rate, is defined as the CPI in the current year divided by the CPI in the original year times 100 minus 100. So we need two CPIs in order to figure out what the inflation rate or the change in prices is going to be. The current year is always going to be the year that is the closest to us, and the original year is going to be the year that is the furthest away from us if we want to make that a little bit more general. And the reason why this formula is so important for us is because it is simply a percentage change formula. We can go ahead and insert any number of variables that we want in order to find the sort of percentage change for that variable. If we want to insert incomes into this, income in current year divided by income in the original year, it'll give us a percentage change in income. If we wanted to use the GDP deflator instead, we can say GDP deflator in current year divided by GDP deflator in original year, and it'll also give us another measure for inflation. And we're going to be using the same exact equation in order to figure out the economic growth rate, the GDP growth rate. We'll put the GDP growth rate, the GDP in the current year divided by the GDP in the original year, and that'll give us exactly how much our GDP is growing by. So this percentage change formula, very important. Be sure you know all the ins and outs of it. And because this is mathematics, there are different formulations of this sort of percentage change formula. You might have used the more typical one, which is the final value minus the initial value divided by the initial value times 100, you'll get the same exact answer. Here, this is just one of the formulations that I'm providing to you in this instance, and the one that we are going to be using. So using the second formula right here, let's go ahead and figure out what the inflation rate is from 2018 to 2019. So here we have the inflation rate. And we use that formula that we just mentioned. Here, the CPI in the current year, or the year that is closest to us, is 115. That's 2019. The CPI in the original year, or the base period, the year that's furthest away from us, is 100. And then we fill out the rest of the formula. We multiply by 100, put this in brackets, orders of operation matter. We minus 100 in this instance, and when we simplify this as much as possible, we get 15%. So here, what does this tell us? The interpretation, it tells us that inflation increased by 15% from 2018 to 2019. So inflation increased by 15% from 2018 to 2019. That's what this number tells us, this inflation rate. And it's a little bit trivial for us to do the inflation rate because we're just comparing things against the base year. Anytime we compare the CPI against a base year, we're going to get a very simple calculation because these 100 sort of cancel out. So we can just take 115 minus 100 or whatever CPI we have minus 100 to get the inflation rate. We don't necessarily need to compare two CPIs in consecutive years to one another, but we're still going to use the same formulation with the inflation rate in order to calculate it out. So suppose I give you another example right here. Suppose that I tell you that, we'll put this example 2 in this instance. So example 2. Suppose that I tell you that the CPI is equal to 238.6 in 2016, and the CPI is equal to 224.9 in 2011. So using the accurate numbers in this instance. So we don't have two consecutive years in this instance, but can we still find out an inflation rate? And the answer is yes, by using the formula that we laid out right here. We just need to be consistent about what is the current time period versus the original time period. Remember that we said that the current time period or the current year is the year that's going to be the closest to us, and the original year is going to be the year that is furthest away from us in terms of time, in terms of distance. So using that same formula, we can go ahead and calculate out the inflation rate from this. So here, what is going to be the current time period? The current time period is going to be 2016, so that's where the 238.6 comes into play here. The original time period, that's the year that's furthest away from us, that's 2011. That's where the 224.9 goes in the denominator. And then once again, we just fill out the rest of the formula. We have times 100, put the brackets here, orders of operation, minus 100, simplify as much as we can, and that tells us we get an inflation rate of 6.09%. In interpretation, it tells us that inflation prices for this market basket of goods and services increased by 6.09% from the year 2011 to the year 2016. And this is the most typical way that inflation is reported nowadays by the BLS. They basically just compare the cost of this market basket of goods and services in one year. They compare to that cost of market basket of goods and services in a base year, and they use this inflation rate formula in order to calculate out and say exactly what inflation is going to be for the United States in this instance. So if you are interested in this type of sort of formulation, we'll go ahead and take a closer look at application of how the BLS actually does this in the press releases that they release every single month in the next video. But now you have a better idea of the CPI and the inflation rate and the numbers that are going to be interpreted from that.